Hi, I'm Jude. Welcome to my Java programming course. In this lesson, we are going to learn about generics in Java programming language. This video is part of a complete Java course I have published on YouTube. If you are interested in becoming a Java expert, I would highly encourage you to check out the rest of the videos as well. This video I have broken down into three different sections. First and foremost, we will learn about what is variable casting is. Then we will learn about what is the type parameter when it comes to Java and generics. Finally, we will learn about wildcard typed variables. I have a small disclaimer to make. This lesson is the hardest lesson in the entire Java programming language. Therefore, I recommend you to save this video and watch it multiple times until you familiarize and understand everything that I'm teaching in this video. Once you understand everything, you nearly understand about 70% of the entire Java programming language. So that is something to be proud about yourself. When we create any variable in Java programming language, it can be either a primitive or an object type. Primitives or primitive data types are inbuilt to the Java language itself. And we only have 8 different primitive data types. We cannot create our own primitive data type. On the other side, objects we can create from the existing Java classes, or we can even create our own object type by simply creating our own Java class. I have shown you this exact table multiple times during our course. I cannot truly emphasize enough how important this table is. As a great Java developer, you must clearly understand these 8 primitive data types along with their size allocations. By having this fundamental knowledge around primitives and their size allocations will make you stand out from good Java developers as a great Java developer. As you can see, we have two different variables from integer primitive and the primitive double type. And what we are trying to do here is we are trying to allocate or assign the smaller data type into a larger data type variable. It is naturally possible because Java knows there is no possibility of any data loss. However, the real question is, can you really do the opposite? Yes, we can do that. This is what we call as casting a value to a specific data type in Java. Here you can see I have instructed Java forcefully to make a conversion to a smaller data type value. In this case, there is a possibility of data loss, and I'm taking the full responsibility and I'm accountable and instructing Java to do this forceful transformation. So the new variable will definitely have some data loss. Now you might be curious, can you really do the casting among objects? Yes, that is also possible. However, it has to make some sense when it comes to the casting type and the variable data type. For example, here I have shown you a very simple inheritance hierarchy. We have the A class and the B class and the Z class. You can see both B and Z classes are extending from the A class. And you know, my dear students, any Java class you create will be automatically extending from the object class. Object class is the root class that all the objects are inherited automatically. Now, according to this particular example, you can see B and Z are subclasses that are extended from the A class. In any scenario, a subclass can always represent or act as the parent class. Therefore, the B instance can be assigned into a parent type reference. You don't even need to cast an object whenever you have a child class assigning into a parent type reference. However, whenever you have a parent type and trying to assign it to a child class reference, you have to explicitly mention the data type. This is what we just learned, the casting. Therefore, our AB reference can be assigned it to a B reference type variable. Here is the confusing part in this example. You understood that the AB is the reference of a A class type. That means in this example, it is the parent class for both B and Z type. Now, what we did in the second statement, we have assigned that AB reference into a B type while casting it into a B type object. So this is allowed at runtime. We didn't even have any problems. Now let's look into the last statement here where we are trying to cast it into a Z type. You have to look from the eyes of the variable data types only. So the AB, what is the variable data type? It is the variable data type of class A. The target data type is Z. So A and Z classes actually have the inheritance hierarchy, the relationship. A is the parent and the Z is the child. If these two classes didn't had any inheritance, Java will not even compile it. But the problem comes not at the compile time. We have a problem coming at the runtime because Java assumed that the AB reference did had an object that is compatible to cast into a Z type. If we zoom into this example, the class B and the class Z have no direct inheritance relationship. Therefore, at runtime, you cannot take a B object and cast it into a Z type. At runtime, you will get a class cast exception. This could not be detected at the compile time because the compile time we are checking the variable data types, or in this case the reference types. Reference types are completely valid because at compile time what Java says is we are trying to cast a parent type into a child type. Unfortunately, at runtime Java says the object what we are holding in the A reference type is not compatible into the expected Z type. So in this quick example, I'm going to showcase the difficulty you might face if you do not use generics in your day-to-day programming in Java. So if we create simple object from the ArrayList class, what do we get here, my dear students? So when you write the ArrayList, you must import the ArrayList class. So here you can see I have imported the ArrayList class. Now if I run this program, what output do you expect? I will not get any output because I have simply created an ArrayList object and does not do anything with that. I don't even have a reference to do anything. So first, let's assign this object into a reference and then we can utilize the reference to do any operations from that object. Here what we did, we simply created an ArrayList object and added 3 elements into that object. You know, my dear students, you can read the elements from the ArrayList object using the get method. Now we are getting a compile time error. Compile time errors are before you run the program, Java will run a verification of your code. So the compile time errors happens even before your program starts. So with the knowledge that we learn in this lesson, let's try to cast this into the expected integer primitive type. Now there is no compile time error. Let's try to run the program and see the output. Here you can see the first two iterations we didn't have any problem. However, in the third iteration, we are getting an runtime exception. This is actually a class cast exception. If you remember, the class cast exception happens when we try to cast incompatible object types. In our example, you can see we are trying to cast into the integer primitive type. However, the problem happens in the third iteration. We are having a string object. We are trying to get this string object and then we are trying to cast it into a integer primitive type, which is not compatible. In this case, what we can do a conditional check before we even cast this object into the primitive data type. Instance of is a reserved keyword in Java. You can utilize this instance of operator to check of a given type. However, you cannot use the instance of operator for primitive data type. This can be only utilized for checking object types. In this case, what we can do is we can check for the integer wrapper class. Inside our if condition, we are guaranteed that whatever the object that we are getting from the array list is a instance of wrapper class integer. Similar fashion, we can also write another if condition to check a given object is a type of string. Now you can see we are not getting the class cast runtime exception because we have individually handled both the cases that can happen. However, this is totally unnecessary. We could have actually utilized the generics feature in Java. Let me show you how to utilize the generics. When we create the array list object, we could restrict what type of elements that it can store. We are utilizing the variable to perform all the actions in the object. Therefore, you have to specify the restricted data type in the variable data type as well. Now you can see we are getting actually a compile time error in our line number 9 because we are trying to add an incompatible data type. So let's remove this line. So now we are getting another compilation error because all the objects in our array list are now integer wrapper class objects. So checking here is the instance of a string is no longer valid. Therefore, Java will not even compile, complaining that these are anyway not related and not compatible types. And that is the integer wrapper class and the string class. So let's remove this unnecessary block as well because we are not going to have any string objects inside our myref array list object. Now that we are guaranteed that our myref can only contain integer wrapper objects, we also don't need to check for every individual iteration if the object is integer wrapper object. The beauty of using the generics is that you also don't need to cast because we are guaranteed that every object is a integer wrapper object. In this case, the type that we have restricted, it's the integer wrapper class type. From Java 1.7, there is a slight improvement to this particular statement in line number 6. Whenever we are creating an array list object with a restrictive data type, you don't have to mention the restrictive data type at two places. That means if you define the restrictive data type within the data type of the variable, you don't have to mention it when you are creating the object. In this case, you can leave the restrictive data type as empty when we are creating the array list object here. Alright students, can you check this example and tell me what can go wrong here? The problem, it's not the part where we insert the data into the list, but the part where we are reading from the list object. You can see we have added here a primitive Boolean data type value. However, whenever we are reading, we expecting that everything will be integer primitive compatible data type. In this case, the integer wrapper class. The Boolean is not compatible into a numeric value. Therefore, you will get a runtime exception that we are trying to assign incompatible data types. To solve this problem, you can utilize the generics. In this case, you can restrict the list object at the time of creation. So the compile time itself, Java will catch any places that we are trying to insert incompatible data type objects. Well, my dear students, from now on, whenever you are creating an array list or linked list or any other collection data object, try to utilize this restrictive data type because that will restrict from incompatible data to be inserted into that particular collection object. As you can see here, you can actually mention any object type under the restrictive data type. But have you wondered how does Java really knows that whatever the type you mention as the restrictive data type will be the type of all the objects that is going to be stored in that object? For example, let's imagine that we are going to create a list that going to contain only apples. So we will naturally mention the apple under the angle brackets. This type will be automatically inferred or automatically copied into the array list here. So ultimately what we have here is a list of apples. It's not list of anything else. It's a list of apples only. So the similar fashion, if we think about, we are going to put the banana as the restrictive data type, it will be automatically inferred into the array list object. So the result is we have a list that can only inserted or only contain the banana objects, nothing else. So here is the same story. Whenever you have the bird as the type parameter, you will get an array list of type birds, and the result is you have a list of birds. I hope you understand the trick here. Whatever the type you put under the angle brackets will be automatically inferred into the underneath class. However, when the Java developers were writing the list interface, they had to define some method signatures. And those method signatures involve the exact data type that we are dealing with. How did they know to refer that exact specific data type? This is what we call as the type parameter in generics. Type parameter only represent a object type. It is not an object, it is a data type. In this case, it's a name of a class. So this is the heart of the entire generics theory. My dear students, the whole point of generics in Java is basically to write more concise and clear code that does not give you surprise runtime exceptions, especially when it comes to the object casting. First, I'm going to create a simple class called gift. The idea is whenever we are giving a gift to someone, we usually wrap the gift to make it a surprise for the receiving person. So let's try to code this as a simple example to understand the necessity and usage of generics. So here in my set item method, I need to put some object as the gift. Okay. So the idea is gift will be wrapped later. So in this example, what can I think of as the input for the set item method? So at this place, I cannot simply be specific to a one data type because I don't know what object that I'm going to gift. Actually, I can use the object class to represent any class in the Java programming language. So let me utilize the object as the type of the data type that I'm going to receiving into the set item method. So my goal is any object that I'm receiving, I want to store and wrap it, and later the person who receives the gift will be able to unwrap that object. Therefore, I will introduce a private field from the object class type called obj. Now let's head back to our main method and let's create some gifts. So here is the scenario. I'm going to give a gift to my mother. So I have set the object as the flowers. So later my mother receives the gift object and she's going to unwrap it. Now the unwrap method returns some value. We need to store it into a variable. Now you know from our unwrap method, we actually return an object data type. You can see here the return type is the object. Therefore, we cannot take the return value and assign it to a string type variable. Let's cast this value into string type. Okay, now let's create another gift for my father. Here also you can see we are actually getting from the unwrap method is an object type value. That value cannot be simply assigned into a integer primitive variable called money. So I have to cast the value into the integer primitive. This is completely valid Java code. However, the only troublesome part here is that we have to forcefully cast the object value into the expected data type. So let's try to avoid this by simply utilizing the generics. Let's look into the example where I gave gift to my mother, which is basically a string value. So if I go back to my gift method and change the object into the string type as their variable return type, I will get an error because the variable that we stored inside the gift is actually the object type. If we change this to string type, we have to change everything into the string data type. If we switch back to our main method, now our first scenario where I set the value as the string value will works without a problem. However, the gift for my father will not work because this is not a string. Now the problem here is you can see the gift class can only contain the string items as the gifts. I cannot put anything else just like here. It will not compile. I hope now you can understand inside our gift class, we cannot specify a specific data type for the item. So let's undo the changes here and switch back to our gift class to utilize generics to solve this problem. Whenever you are introducing a type parameter into a class, you have to specify it soon after the class name. Now this is the type parameter. You can write anything as the type parameter label. Here I have given my type parameter as the label for my type parameter. So this represents an object data type. So let's utilize this type parameter inside our gift class body. Now it is important to remember that this type parameter only available inside this class body scope. If we switch back to our main method, we still have not utilized that type parameter. If you remember when we create the array list, you specified the restricted data type. It is actually the type parameter. So here you can specify inside the gift for my mother, I'm going to store string, not anything else. The best part is now you no longer need to cast these variable values. They are already compatible because at the time of creating the gift objects, we specify what type of item we are going to store inside our gift object. Let's quickly switch back to our gift class. I want to show you that whenever we are defining the type parameter, we usually write a simple letter because we can overlap this label with an existing Java class here. For example, I could write this as the demo. It works, but as the developer, this demo is not the class of the demo because this is more like a placeholder. So let's not mix the placeholder with an existing Java class. Therefore, usually when it comes to generics and the type parameter, we define that type parameter as a single letter. Usually in Java, we use the capital T letter because I think nobody will create a real Java class called T. That doesn't make any sense. But when it comes to this placeholder that is only available inside our defined Java class, it makes more sense that to write it as the capital T letter. You can also write multiple type parameters, separating them by comma sign. Now the last theory around this type parameter is that you can define a bound when it comes to the type parameter definition. Now let's assume that you are only giving money as gifts, not flowers. So in that case, we can actually restrict this particular type parameter to be anything of numbers. We can actually define an upper bound to our type parameter. So in this case, the generic type parameter can only be some object that has extended from the number class. We have defined an upper bound or upper limit to our generic type. Now, if we look back to our main method, you can see the line number 5, the type is not compatible here because string is not actually extended from the number class. So we have to provide a type that has actually extended from the number abstract class. So let me change this into our double wrapper class. So now you can see at the compile time, Java has identified that an incompatible value has been passed into the set item. This is the real advantage of utilizing the generics, because at compile time itself, Java can figure out incompatible data assignment. Here are a few rules when it comes to the type parameter. Type parameter is only accessible within the defined scope. That could be a class body or a method body. Type parameter cannot represent any primitive data type. If you want to represent the integer primitive data type, this is where you have to utilize the wrapper class for that integer primitive. Here is the most interesting rule when it comes to the type parameter. Here you can see I have created an array list of strings and trying to assign it to a variable of type array list of objects. This is not allowed because when it comes to the generics, you cannot think about the inheritance for those generic types. Generic type is an independent type which is bounded to that class type. In this case, the array list of objects is not equivalent to the array list of something else. According to our last example, the gift of objects is not equivalent to the gift of strings. Even though the string class is a subclass of the object class, when it comes to the generics, you cannot think about the inheritance hierarchy. The type parameter is always looking for that exact same type. It does not satisfy with a subtype or a parent type. Now that you have mastered about the type parameter, we are going to learn about the wildcard types. This is the last section of this lesson and it can be the most confusing part as well. So before I even begin, I want to make clear that the type parameter that we have learned has nothing to do with these wildcard types. Wildcard types are dedicated for variables. The type parameter that we have learned so far is only applicable for mainly the classes. So please, my dear students, don't get confused with the type parameter and the wildcard types. Wildcard types only have 3 different variations. It is the unbounded, upper bounded, and the lower bounded. When it comes to this topic, we are not going to use T, E, or any other notation to represent any type. In this case, the type is being represented as the question mark because it's a wildcard. Wildcard means it's not something unique. It can be a range of things. Here I have a simple inheritance tree. We have a shape class as the parent class. The circle and the square are immediate children, and the ball class, it's extending from the circle class. As you already know, any class which does not extend from an existing Java class will be automatically extended from the object class in the Java programming language. And that is why our shape parent class is being extended automatically by the object class. Here in this case, I have simply created a class called gift with the use of type parameter. The type parameter can represent any type you can imagine. All the classes in our example inheritance tree can be represented as the type parameter value. According to this new type parameter definition, we are only allowed to pass the type as the circle or any of its subclasses. Here in the examples, the object type will not be compatible because the type parameter, we have an upper limit. So any type that you are passing must satisfy this upper bound type parameter restriction. Now we are talking about the wildcard types. Wildcard types are applicable when it comes to the variable types or method input parameters. So here I have a method called myMethod and it has an input parameter of type gift unbounded wildcard type. So this means when we are calling the myMethod, you can pass any type of gift. In this example, we have 3 gift objects. You can pass any of them into the myMethod because the myMethod signature allows any type of gift. Now the second variation when it comes to the wildcard types, it's the upper bound. It is very easy to understand where we define an upper limit. According to our inheritance tree, we can pass the gift of circles or gift of balls or any other subclass that is created from the circle class because our upper limit is the circle type. Here we have the lower limit wildcard type definition. You can see when we have the lower limit, all the parents and the super parent types are compatible. In this example, our lower limit is the circle type. Therefore, the circle type, shape type, and the object type is compatible to be the gift type parameter value. Now that you know, we cannot call the my method by passing the square gift because it is not a parent for the circle type. Alright, my dear students, we came to the end of our generics lesson. We started this lesson understanding about the variable casting. We also understood there is a problem that can appear at the runtime when we are casting objects into incompatible data types. And this is the reason why the whole generics framework has been introduced to the Java programming language. Then we learn about what is the type parameter in generics. We learn about that we can actually restrict the type parameter using an upper bound limit. We talk about few restrictions and limitations when it comes to the type parameter. The final and the most interesting section of this lesson was to understand about the wildcard type variables. There we had three different variations: the unbounded type variation and the upper bound variation and the lower bound variation. And I am happy to tell that we have actually covered entire generics framework. With this knowledge, we are ready to jump into the Streams API. It is a very interesting and fun API to work. So I hope you will join my next lesson where we are going to learn about the Streams API in Java.